As Fernando mentioned, my name is Manisha Shah. I work for the National Renewable Energy Laboratory here in the Washington, D.C. office. Today we will be presenting on the latest thought leadership report from the 21st Century Power Partnership called Clean Restructuring Design Elements for Low Carbon Wholesale Markets and Beyond. This report was recently published and launched at the Clean Energy Ministerial in late May of this year. I'm joined today by two of my co-authors, Jose Maria Valenzuela and Hector Beltran, who Fernando introduced earlier. So let's get started. As Fernando mentioned, we will today give a brief overview of the 21st Century Power Partnership Program. I will lay out what we mean by clean restructuring and how it's described in the report. Then I will review some of the high-level takeaways from the main report. And then Hector and Jose Maria will dive into one of the primary examples of clean restructuring with a Mexico case study. Our moderator, Fernando, as he mentioned, will be collecting questions via the webinar system, and we will address them all at the end in the Q&A session. Just a little bit of background about today's speakers, which Fernando already provided. But again, I'm Manisha Shah, and I work at the National Renewable Energy Laboratory here in Washington, D.C. You see here also Jose Maria Valenzuela and Hector Beltran. They were two of the co-authors for this study. We were also very fortunate to have additional co-authors, some of whom might be on the call today as well if there's additional questions. We had a team from Denmark, the Danish Energy Agency, and they wrote the Danish case study. There were also two colleagues of ours from Ecofis, Fabian Wiegand and Silvana Tiedemann, who wrote the German case study. Also for the main report, we had colleagues from National Renewable Energy Laboratory, Lori Bird, Owen Zinnemann, and Jeff Logan. And Lori Bird is also on the line with us today. The 21st Century Power Partnership is a unique platform to support the development of clean energy approaches and power systems transformation. We have fostered multilateral engagements, and 21st Century Power Partnership ensures that global insights into the common and divergent features of power system transformation are being shared across the different member countries and participants in the program. The initiative improves the efficacy of clean energy reform agendas and ensures that participating governments have access to international experts and resources. There's three different aspects of the 21st Century Power Partnership. There's the Power Partnership Steering Group, which is made up of representatives from clean energy ministerial governments and meets regularly to review partnership activities, establish specific activities through a program of work, and ensure that the partnership's work complements and leverages other clean energy ministerial activities. There's also a Public-Private Leadership Forum, and the PPLF coordinates activities with private sector stakeholders, including utilities, system operators, technology suppliers, investors, project developers, and financial services firms. And then National Renewable Energy Laboratory is one of the operating agents and manages many different aspects of the 21st Century Power Partnership. In addition to these three different components, there's a lot of also country work that's going on in India, Mexico, and South Africa, and the 21st Century Power Partnership is bringing global experts together with governments, utilities, and regulators to facilitate increased renewable integration in the deployment of large-scale energy efficiency and smart grid solutions in these countries. So now let's talk more about the report. The Clean Restructuring Report builds on a 21st Century Power Partnership report that came out last year called Power Systems of the Future. The Power Systems of the Future report articulated emerging trends in power systems transformation across the globe and also laid out 5 potential pathways for power systems transformation based on specific starting points and end visions. Clean restructuring was one of these pathways, which, as you can see in this graphic here, is moving from a fully vertically integrated electric sector to one that is fully restructured in one big set of policy reforms while creating an environment that's friendly and inviting for clean energy. This report focuses primarily on the transmission and bulk power system aspects of restructuring, though we recognize that restructuring may also include the creation of retail competition as well. We also recognize that there is a large volume of existing literature on electric sector restructuring, and this report builds on all of that, but focuses primarily on the design of a newly restructured wholesale market that can accommodate high levels of clean energy, including variable resource renewables, demand response, electric vehicles, and other clean energy options. Three aspects of clean restructuring were explored in this report and are featured in the middle of this graphic. Planning and procurement of generation and other resources, customizing market design and system operations, and updating grid interconnection, expansion, and codes. The main body of the report was also accompanied and brought to life by 3 case studies for 3 different countries, for Mexico, Denmark, and Germany. One of the reasons that clean restructuring requires specific conditions for market and policy design is that increasing levels of variable resource energy introduces unique conditions for power systems. First, unlike more traditional forms of electricity generation, wind and solar resources are variable in nature and thus introduce uncertainty into the power system with respect to the electricity that can be expected in any given hour. Second, wind and solar resources can vary significantly by region, and new generating capacity may or may not be located near load or transmission availability. And in the restructuring process, markets can be designed to better address these issues. Systems with high levels of variability with respect to load and generation may require the system to be more flexible or be able to respond to changes in demand and supply quickly. This graphic here depicts a number of different options that can be used to increase the flexibility of a system, such as generation, transmission, demand-side resources, and system operations. And some of these considerations with respect to market design and policy for clean restructuring have been laid out in this report with an eye toward increasing the flexibility of a power system. So one of the first areas of consideration in the report is how long-term planning and investment decisions may be made in clean restructured environments. They certainly may become more complex. For example, in a vertically integrated system, a state-owned enterprise or a handful of primary utility companies that are vertically integrated in a concentrated set of actors may be involved with planning and making long-term decisions with respect to investments in generation. Whereas in a restructured market, a system operator may be conducting long-term planning, while a set of very dispersed investors and private sector entities are making long-term investment decisions in generation, and now also other clean energy resources. For example, demand response storage, or in the graphic here, combined heat and power, as we see had occurred in Denmark. Second, with different entities planning the system and different entities procuring or investing in clean energy, a diversity of interest may arise from different market actors and the system operator. Third, with increasing levels of clean energy in the system, traditional and new generators might experience revenue sufficiency issues with respect to traditional market designs. In a competitive market, revenue sufficiency is a concept that price signals will encourage the type of generation or other resources in the system needed to cover peak load and generation outage conditions. However, certain characteristics of markets with increasing levels of variable resource renewables have led to revenue sufficiency concerns. For example, renewable energy often has low marginal prices and then are often dispatched first in an economic dispatch system. For non-variable resource generators, they might then be receiving a lower overall market clearing price and then be dispatched less frequently. In addition to this, some of these systems may be experiencing an excess of capacity beyond reserve margins with an existing fleet of older generating units and increasing levels of variable resource renewables entering the power system due to policy objectives. And a few markets have sought to deal with these circumstances. Germany, for example, last year launched an effort to explore market design approaches for addressing revenue sufficiency concerns as well as other issues. And this is featured in the German case study in the report and resulted in their new Electricity 2.0 design. ERCOT, which is a wholesale market in the state of Texas, also went through a process to address some of these issues and considered supplementing their energy and ancillary service markets with a capacity market in 2014. Some of these topics are highlighted in further detail in the report. However, there are various practices and strategies which can be taken to improve planning and procurement processes in power systems with high levels of clean energy. First off, one can enhance foundational planning and data, such as including high-fidelity wind and solar data, and including flexibility assessments of the power system, including undertaking energy efficiency and demand response potential studies. Secondly, one could also enhance system planning practices, such as undertaking more integrated generation and transmission planning and using advanced flexibility metrics and constraints in planning analyses and exercises. And lastly, one could also enhance market structures and procurement practices, such as including scenario analyses, providing better grid expansion expectations to generators and investors, and several other practices which will be explored further in the report and also in the presentation. Next, we move to the secondary consideration explored in the report for clean restructuring, which focuses more on how short-term market rules and system operations can be better designed in a wholesale market to accommodate clean energy options, including those that are variable in nature. In a vertically integrated power system, the utility may have decided the scheduling and dispatch of generators. In restructured markets, oftentimes there's an independent system operator who dispatches generators on a least cost basis or a security-constrained economic dispatch, as in the figure above. Scheduling and dispatch and other market rules can be designed to better integrate variable resource energy and also encourage the use of practices which increase the flexibility of the system. For example, faster dispatch or dispatching generation every 5 minutes can help to effectively utilize available variable resource energy. Variable resource energy that is also dispatched in 5-minute increments can maintain a relatively steady output over time and is more likely to remain at the generation set point. The use of intraday markets and shorter gate closures can also be helpful and lead to more efficient market operations by enabling renewables to provide more accurate information about their expected potential output. Another practice is to create a larger balancing area, which can enable the system to operate with less variability and more flexibility. Greater geographic distribution of renewable resources can reduce the system-wide variability because weather patterns are generally more diverse if considered over a larger region, and can also reduce aggregate forecasting errors. Another practice, an area of improvement, could also be the rules with respect to curtailment. This is an important consideration for markets with substantial penetrations of renewables because there may be instances where renewable curtailment is the most economic means to balance supply and demand. In addition to these practices, there's also several others that were explored in the report. Forecasting the potential to change ancillary service markets and also additional and new market products which are emerging. The integration of forecasting of variable resource renewables into market operations is important for operation and economic efficiency. Forecasts are important both at the system operator level as well as for all generators and market actors, even including demand response providers, for maximizing revenue and also for the market operator to maintain system reliability. Forecasts can reduce the amount of conventional generation committed in the day-ahead market and also improve the efficiency of operations. Forecasts can also enable the system operator to ensure that adequate capacity is brought online to meet demand when significant storm events are predicted. Also, the design of imbalance penalties that are assessed when scheduled generation deviates from actual delivered generation can be important for effective utilization of renewable generators. These penalties can also encourage improvements in forecast quality. Also, the way that ancillary services are provided may need to change in systems with additional clean energy to encourage new forms of ancillary services and also allow for new resources to provide ancillary services, even including variable resource renewables. For example, when there are system disruptions, traditional power generators can provide inertial response, but with systems with significant levels of variable resource renewables, which are non-synchronous resources, inertial response may be needed to be incentivized and could be provided by wind generators that have the right power electronics technology. New market products are also emerging, such as ramping products. For example, from California Independent System Operator, they have a new product called FlexiRamp, and these products may be helpful for achieving additional system flexibility to support and address the variability and uncertainty of variable resource renewables. Lastly, demand response can also be a very cost-effective component of system flexibility for all three different types of markets, for energy, ancillary services, and capacity markets. Demand response providers can provide spinning, non-spinning regulation, and load following services depending on the time frame. Demand response providers are also experimenting with different technology options, such as water heaters, electric vehicles, water pumping, and space heating. But there's a need to address certain barriers in order to enable demand response to play a role in these different markets. They need to be able to participate in all energy markets. There needs to also be access for third-party aggregators, the ability for various technologies to be eligible to play in demand response, and also working with market prices to properly value the time value of electricity. The third area of consideration explored in the report was transmission, grid expansion, interconnection, and the updating of grid codes. In a restructured environment with significant clean energy resources, key policy and regulatory considerations are with respect to how to expand infrastructure investment to accommodate clean energy resources and appropriately allocate cost and risk of network expansion among both developers and ratepayers in accordance with policy goals. One way to address this is by encouraging integrated generation and transmission planning. For example, in Texas, there were high-quality wind resources, but they were distant from large load centers, and the investment timeframes for developing variable resource energy deployment as well as transmission extension were not aligned. There was a co-investment conundrum. So the state legislature gave the Public Utilities Commission of Texas the authority to conduct a planning process to create competitive renewable energy zones. And these identified areas to build a few strategic high voltage lines based on wind potential. This practice, which involves a diverse set of constituencies, has also been adopted in Mexico. The case study authors may discuss this later. It's also important to streamline the interconnection process for resources applying to connect to the network to reduce the project burden in terms of time and resources needed for the application process. Interconnection queues impact the ability of generators to connect to the system and the cost they may face for interconnection. And in a system where you're trying to encourage a lot of clean energy from a diverse set of resources, interconnection can play a huge role. Queues can be more efficiently managed through various practices to weed out less serious applicants, conducting the queue more cost-effectively, and streamlining the process overall. For example, interconnection assessment fees were adopted in Mexico based on previous experience with the interconnection process. In Ireland, the system operator created a queue management protocol called the GATE system, by which a group of applicants with unique criteria could be processed together. Lastly, grid codes, or the rules addressing how generators or other resources must connect to the electric power grid in order to maintain system reliability, can also be updated to reflect the necessary requirements that enable system reliability and reduce curtailment. Modifications can be needed for grid codes for variable generators pertaining to power control, reactive power and voltage control, frequency and inertial response, and voltage and frequency ride-through. Many of these details are featured in the report, as well as many other 21st Century Power Partnership resources. Lastly, I wanted to talk about the 3 case studies very high level because we're going to get a nice feature from the Mexico case study authors. But the case studies were a wonderful addition to the Clean Restructuring report in that they really brought to life many of the 3 areas of consideration. And the 3 areas of consideration were built upon examples and best practices that were collected both from 21 CPP members as well as other examples from across the globe. The 3 case studies include one from Mexico, which we will hear from in a moment. They are undergoing a rapid restructuring through a sweeping set of power reforms which have been specifically designed for the integration of clean energy. In Germany, they underwent a public process last year, as I mentioned earlier, to discuss how to update their currently restructured market to address some of the revenue sufficiency issues and increase their ability to accommodate more clean energy and encourage flexibility. Lastly, the Denmark case study explores their remarkable ability to leverage regional cooperation with their Nordic neighbors to create a larger balancing area. So with that, I will turn it over to our Mexico case study authors, after which we will take have a question and answer session. Hector?
So this is Jose Maria Valenzuela from WWF Mexico. I'll take a few minutes to talk, then Hector will complement me. We'll move back and forth between myself and Hector. I work at WWF, World Wildlife Fund Mexico office. we're very glad to participate in the report based on our work regarding the support that we provide to the government in terms of the relevance of maintaining coherence between energy policy and climate policy, and in particular, being a key backbone of that coherence element, power sector reform policy. So I'll start talking about the context of reform in Mexico, which has been occurring in the last 2 years and a half. Mexico power sector market evolution actually was developed in parallel to other opening up of energy markets, including oil and gas markets, which were primarily state monopoly, just like in the power sector. And the key drivers to actually engage in power sector reform were first to reduce the cost of supply through market efficiency, again to reduce the cost of supply through the change in the structure of energy production away from heavy fuel oil, mainly by accelerating the expansion of natural gas and renewable energies, primarily wind in the short term. It's more clear that solar is going to have a bigger role to play in the restructuring of the new structure, production structure of Mexico power sector, and finally to comply with the climate and energy transition mandates. First, to comply with the 35% mandate of clean energy in the power sector by 2024. In Mexican legal jargon, clean energy includes not only renewable energies in the more conservative fashion, but also large hydro and also nuclear energy, the potential of having fossil fuel-based carbon capture and storage, and up to a certain point, certain contribution from high efficiency combined heat and power systems. Just to set up a little bit of more background for the discussion, Mexico has a quite robust power system by many indicators, including power access. We though still have about 1.52% of the population without access to electricity, but this means comparing to other developing countries, that access is not anymore the main concern of the power system evolution. We do stand as one of the major geothermal power generators with a capacity that is almost equal to 1 gigawatt. It's obviously to the whole size of the system, which is about 65 gigawatts. It's still little, but we do hold the 4th place in terms of total output of geothermal generation. And one of the key elements that stand out for Mexico, as it is in the case for other developing countries, our technical and non-technical losses are very high compared to the average of the OECD countries. We stand out as with technical and non-technical losses about 16%. So one of the things that we do know stands out from Mexican energy reform process is the speed that, in which it is taking place. So by December 2013, we had the constitutional reform proposed by the President first, and then negotiated and approved by the Congress, which allowed for the state-owned enterprise monopoly to move into a wholesale market. So we have the constitutional amendments in December 2013. Then 8 months later, we had the implementing laws, which included laws for the power sector market structure, laws on restructuring CFE, the state-owned utility, and the law that creates or changes the nature of the regulatory commissions, and that creates and provides a key framework for having an independent system operator, And we also approved a geothermal law during 2014. Also, at the same time, or just a few weeks after these laws were passed at the Congress, officially the ISO was created. So the Independent System Operator, or SENACE by its acronym in Spanish, was originally a body within CFE, the state-owned utility, while it was vertically integrated. So what occurred is that there was no need for a new body to be created, just for giving independence to this body previously based within CFE. Before the end of that year, before the end of 2014, then the first criteria for providing clean energy certificates were established. And that allows me to talk about one key point, which will come back later, the fact that as a key component of the market, of the new market structure, there is the obligation of, or there is the possibility of the government to establish obligations for large consumers and the suppliers to the public to purchase at surrender to the government, to the regulatory agencies, a certain amount of clean energy certificates every year. And we will talk about it with more detail further on. Then in 2015, by March 2015, just 6 months after these criteria were issued, the government established the first clean energy certificate requirement 3 years ahead before the year of compliance. That is, the government established the certificate mandate for 2018, and we'll go back into that when we talk about the long-term energy auctions. By that summer, new interconnection criteria and a first new system expansion program were presented, including new projects for public-private partnership investments in transmission. And as months folded in 2015, the new power market rules were established. The testing of the real day-ahead and real-time market initiated, and specific issues on interconnection contracts and regulation for open access on transmission were developed. Before the end of 2015, and while the Mexican government, the president, was attending the Paris conference of the UNFCCC, a new law was approved, the Law on Energy Transition, which complemented the sort of substantive laws on market structure to generate certain dispositions regarding the promotion of renewables and energy efficiency in the power sector. So by 2016, this year, in January, we officially initiated the day-ahead market and the real-time market operations. Knowing that CFE still has a dominant role in the power system, and that the actual market operations will certainly have to evolve quite significantly in the forthcoming years. Anyway, we already started with SENACE, our ISO, operating with the new market rules. By March, also the new rules for splitting up CFE, the utility, were set up, so that we will see before the end of this year CFE, or without the ISO already out of its offices, we will see the rest of CFE being split up into different subsidiaries, still entirely owned by the state. And in April, we saw the call. Actually, in March, we saw the call for auctions for the first auction. Sorry, the conclusion of the first auction, which was certainly a success, and we'll talk a little bit about that. And ahead of us, there lays the second long-term energy auction, which is mainly for purchasing renewable energy. energies, and the creation of the establishment of a capacity market by 2017, and ahead as well the initiation of the clean energy certificate markets in 2018. So that's a broad view of what has taken place during the last 3 years. And you will see, while Hector and myself are presenting some of the key elements of the new market structure and market rules in Mexico, that many of the key points established in the report are not necessarily, I mean, let's say the key points in the report are more of a typology sort of approach, while as it is always the case when implemented in a country, in the case of Mexico, there are many traits that are very clearly within the rules but might not yet be on place or fully implemented, or the results might, in this short period of time, might not be evident yet. But still, some of the key elements are there to be discussed and to be explored, already being implemented in the country.
Okay, so I will take it here. Hello everyone, my name is Hector. I work at the Energy Regulatory Commission. I'm responsible for just overseeing and creating new regulation for electric availability and just giving a technical assessment of the new expansion strategies that is going to be proposed for both transmission and distribution sector. Just summarizing and taking some points about what Monisha and Jose Maria mentioned, Mexico is going under a major energy reform that has changed very strongly our energy sector. And I would like to mention something about the new roles of the various sectors that we are involved. As you may imagine, as a result of this energy reform, various institutions in Mexico were given new attributions and new roles. That's why we are changing our internal structure to be able to commit a new strategy to comply with all the new obligations we have in the new laws. I would like to start first with the Ministry of Energy, with CENER. Of course, they are the responsible for setting the policy, the national policy about the energy, which we understand that they are going to set the goals for the long-term, medium-term, and short-terms. Targets for many aspects, such as, for example, smart grid, renewable integration, just a very good example what Jose Maria mentioned, that we have a clean energy target, just to achieve 35% of the electrical energy that is going to be consumed in Mexico by 2024 has to come from clean energy resources. That's one sentence of policy, but of course we can have many other aspects that can be addressed by the Ministry of Energy. I would like to remark some of the new attributions of the ministry, which are mainly just create the first version of the market rules that Jose Maria explained. They already issued and published. So we have, for the first time in Mexico, a guideline to know how the market is going to operate and what kind of transactions are going to be allowed within that market. Another new element is the creation of the clean energy certificate, which is going to mainly devoted to promote renewable energies. So I think it's going to create a very competitive market, and it's going to be a fostering tool to have more renewable share in the market and the Mexican system. As well, I think a very good element that was included as well is the smart grid policy. For the first time, we have a very specific definition of this concept, and the CENER is responsible for setting the goals for the smart grid in the Mexican context. And finally, regarding CENER, they are taking the lead of the planning process, which is going to change radically. Jose Maria is going to take this a little bit later. But the process of proposing expansion strategies in Mexico has changed because this was a former responsibility of CFE. CENER and the Ministry of Finance were somehow involved, but now all the expansion strategies are developed under technical and economical rationales for having a more efficient expansion. Secondly, I would like to refer to the Energy Regulatory Commission. I think this is the case that I know the best because of work in this institution. And I have to say that we are living a completely change because we grew stronger as a regulator. We have more responsibilities. Before the energy reform, CRB was only devoted mainly to issuing permits for generation. And now we have more specific powers on some other activities, such as tariff regulation, which is very important. CRB is responsible for setting the tariffs for the services of transmission, distribution, ancillary services, imposing penalties, so on and so forth. Another important thing is that we are going to be responsible for issuing all the electric availability regulation, which is quite a challenge because this is completely new. We're trying to take the best experiences we had before with CFE, but of course we're trying to adapt all we have to a new competitive market. After that, I would like to mention something about the new Mexican ISO, which is SENACE. Jose Maria already explained that SENACE was formerly an internal department of CFE. Now, because of the energy reform, SENACE was withdrawn from CFE and constituted as a new independent body created to operate both the market and the system. And of course, they have to be independent just to make sure that we're going to have a transparent and equitable treatment for everyone. So the main responsibilities now for SENACE are to conduct auctions. They are responsible for setting the table and just conducting this process of in which three main products are going to be exchanged, which are energy, capacity, and clean energy certificates. We just saw the first auction in place. We had very, very good results. We were all amazed, just to be honest, we were all amazed about the prices we obtained and to see the real prices of some technologies such as wind and solar. Finally, I think CFE, which is now the new entity of the government, is now an enterprise. I think that they have the role that have changed the most because the previous energy reform, they were a vertically integrated company, which means that they were responsible for doing everything from generation until to final users, to retail. And now CFE was split up at the beginning of this year. Of course, we expected to have three main branches, which were generation, transmission, and distribution. But even more, we have 6 different companies within the branch of generation. They are going to be devoted to offer their energy to the market. They are going to compete among themselves, and they are responsible for just offering energy based on production cost. So the new electricity market in Mexico is going to be a cost-based market. Also, CFE is going to be still responsible for transmission and distribution regarding the physical control. I mean, they are going to execute all instructions that they are going to receive from SENACE. SENACE are going to give some operational instructions, and CFE is going to be responsible to execute it on the field. And finally, the CFE, we can say that they are going to enter into a new business because they are now going to be a load-serving entity. They are going to be responsible for supplying energy, and I think that now we have the new company CFE split it into many different branches, and every branch has to compete, for example, generation to compete among themselves. And just to summarize this slide, we are seeing that in the left part of the slide, we're moving from an industry model which was based on a vertically integrated monopoly to a market-based industry. And here I would like to remark that taking into account this market-based structure, both ends of the change, generation and retail, are open now to competition, whereas transmission and distribution are going to remain under economic regulation issued by CRE. Moving forward, I would like to mention some other 2 very important aspects. One is the grid code. Monisha already mentioned something about the grid code. We have, perhaps you have seen this concept around the world, and you are going to refer that the grid codes refers to the main technical requirements for getting the generators interconnected to the system. Well, we have the same concept here in Mexico, but we are going a little more beyond. We're not talking only about interconnection, we're talking also about planning, also about operation, a smart grid, and some other like a microsystem operation. We're including, this is a very holistic document. And so the Mexican grid code has to be understood as the set of minimum technical requirements to operate and to plan the Mexican power sector. We have based this document on the definition of adequate level of reliability. We are taking as well 10 NERC-like standards because of our physical interconnection between the Baja California and California in the northwest part of the country with the U.S. And also we have included some specific requirements for the development of smart grid. They are mainly based on the principles of interoperability and cybersecurity. And I think that a very important aspect is to say that we are about to create a national reliability committee. We want to come up with this process which is going to be very transparent, in which all different stakeholders are going to be able to participate and to give their opinion, their views, their experience in order to update and to improve this grid code. Finally, one of the main aspects about SENACE's activities is related to the economic dispatch and the ancillary services market. Of course, SENACE is responsible for dispatching the system. They are going to be based on the typical definition of the merit order of variable cost. I think the cheapest technologies are going to generate first, and then the most expensive technologies are going to be the last, giving the energy to the market. Right now, SENACE is computing the LMP's local marginal prices for more than 2,000 nodes. And I would like to say that these 6 months of 2016, we have seen some prices ranging from 48 to 60 US dollars per megawatt hours. We have some zones, for example, Tijuana, which is next to the border of the U.S., which very competitive prices around 20 US dollars per megawatt hour. And finally, we have this formal creation of this ancillary services market. We are talking about the reactive power support, voltage control, some black start operation, some and other services, and CRE is responsible for giving a price or putting a price, setting a tariff for some of them. So with this in mind, I think that Mexico is changing into a more competitive environment, and I give this over to Jose Maria to explain with a little more detail about the next changes we are expecting here for the Mexican system.
Thank you. So we've already covered pretty much every concept that is key to the Mexican energy reform, but just to go back to the backbones of the transformation, naturally having a as the regulatory part Hector already covered, and I'll talk in a minute about the planning system. The unbundling of the state utility CFE, which still has to happen, and there will be a lot of attention to be put onto how the unbundling of CFE relates to the market operation, and the clear rules of wholesale market and the regulation of transmission and distribution. When we talk about clean deployment in particularly, the clean energy certificate system, putting the burden onto consumer, is very adequate for not only developing a robust regulatory system regarding these elements, but also the potential of having more international interconnections. Putting the burden into consumers will make sure that we, by importing energy from the United States, which is the most obvious case, I don't think that will happen with Guatemala in the south, still our share of clean energy consumption, it's the key driver of renewable energy deployment in Mexico. The long-term auctions and the use of high renewable energy zones. I'll talk in a minute about long-term energy auctions, but the high renewable energy zones, as Monisha mentioned, it's a concept that It's similar as a concept to the text and application of this. In the case of Mexico, the law establishes the concept and setups basic principles of how this should be used. But this is very early on their very early development because the concept was approved in the law that passed the Congress just 6-7 months ago. So we will still have to see. We will have to wait 1 year or 2 years to see how this is incorporated into the system expansion planning and also investment decisions. So one of the key elements that were provided, or the key opinions from the private sector before the reform was that there was a very serious challenge on transmission development and interconnection. If the reform had not happened, we would have had very serious administrative bottlenecks for new projects, high regulatory risks for developers, an economic burden to the authority, and a very cumbersome process for the grid planning with a very clear bias in favor of CFE projects. Before the reform, the reviewing authority was CFE, which was also the main generator. Now it's SENACE, our ISO. Before there was no clear time frame for reviewing applications for interconnection. One challenge was that applications were free. That obviously created part of the problem with the bottleneck. There was no scale differentiation. There was no difference between large projects or small projects. And the incorporation into the planning was not very clear as well. Now we have very clear, very standard rules for every participant. And these rules are being implemented by the system operator, by the independent system operator, which naturally provides investors with a more, with a better framework for dealing with the authority rather than dealing with CFE. So the first long-term auction, which, as we mentioned, we consider a success, and we believe everybody has considered it a success. During the auction, 6.3 terawatts year of energy and certificates were purchased or were meant to be purchased. This number comes directly from the mandate to purchase at least 5% of clean energy and its certificates by 2018 from every large consumer and supplier, in this case CFE. And also there was an auction for 500 megawatts of capacity. The energy was to be delivered starting in 2018. So there were quite a lot of offers, 227 offers. Finally, there were only 18 winning bids from 11 companies. Most of the bids were, the most successful companies were actually solar photovoltaic companies rather than wind. That was also new for everybody in Mexico. And most of the energy will come from solar PV based on the particularities of this auction. And the lowest price coming from a solar project was even below $40. And there were no offers of capacity. I won't get into the details of the calendar of the auction. What's most important is to see the diversity of the production of solar and wind, which all of these regions, except for Tamaulipas in the Gulf of Mexico, were previously not heavily or not important renewable energy generating zones. What's also important is that some of these zones, like the Yucatan Peninsula in the southeast of the country, have a very high cost of power in the wholesale market at nodal pricing. So precisely because of that very high price, because of the specifics of these auction rules, which you will be able to see in the paper, a lot of projects got benefited from very high prices in this specific zone, so that the projects, most of the projects were set up in this Yucatan Peninsula that previously had no renewable energy project and was mainly fueled with heavy fuel oil. So I think I'll finish up here to leave time for questions and some comments. if I'm not mistaken, Manisha?